The curve with parametric equations x equal f of t, y equal g of t, where t is between a and b inclusive, has initial point f of a, g of a, and terminal point f of b, g of b. So that leads us into the next example. What curve is represented by x equal cosine t, y equals sine t, where t is between 0 and 2 pi, including those numbers? Our first option is to do what we just did a few minutes ago. Make a t, x, y table, plot a whole bunch of points, and hope we can figure out what our graph looks like. Or we can think about what we know from algebra and trig and use that. So notice that x equal cosine t, y equals sine t. Do I know any relationship between sine and cosine? Yes. What do I know? I know cosine squared t plus sine squared t is 1. So x is cosine t, so this is x squared. Y is sine t, so this is plus y squared equal 1. And what is this picture? If I were to graph this is a circle centered where? Centered at the origin. And what's the radius? 1. Okay, so we may want to just draw our circle and then use our x, y, t table to determine direction, because we still have to figure out which direction it goes in. But I can draw the basic shape right now. Let's do that first. That's a beautiful circle. I know this is the point 1, 0. This is the point 0, 1, and so on. I don't have to plot every single value. There's infinitely many, but I'm going to plug trig values that are nice and easy for me to calculate. So I'm going to start with my favorite 0, then maybe I'll do pi over 2, pi, 3 pi over 2, and 2 pi. I can do more if I need to, but I already know the shape is a circle. So when t is 0, x is, well, remember these points go cosine comma sine, x is 1, y is 0. When t is pi over 2, my cosine is 0, my sine is 1. When t is pi, cosine of pi is negative 1, sine of pi is 0. When t is 3 pi over 2, cosine 3 pi over 2 is 0, but sine of 3 pi over 2 is negative 1. And then I plug in 2 pi for t, I get what? 1 and 0 again? And it repeats, continues on from there. Now, if this did not have a restriction, the circle would go over, around, and around, and around, and around, and around, and around, and around. But since I go from 0 to 2 pi, I know it starts and ends. It has a starting point and an ending point. So what direction will it go in? Let's see. So it starts out at 1, 0. Starts out right here, so this is t equals 0. From there, it goes to 0, 1. So 0, 1. This is t equal pi over 2, and it's going this direction. From t equal pi over 2 to t equal pi, it goes negative 1, 0. And then it goes 0, negative 1, so still along this path. T equal 3 pi over 2, and I keep going because I know t equals 0 is the same as t equal 2 pi. So it is counterclockwise direction. What curve is represented by x equals sine 2t, y equal cosine 2t, where t ranges from 0 to 2 pi? So we look again. Can we come up with a relationship between x and y? We know that cosine squared theta plus sine squared theta is 1. Doesn't matter what theta is as long as it's the same thing. Cosine and sine are both operating on the same value. So cosine squared theta, my theta here is going to be 2t. So this is like writing cosine squared 2t plus sine squared 2t equal 1. That's the same thing, isn't it? Sure it is. So cosine squared 2t, that's y squared, plus sine squared 2t is x squared equal 1. I can write this in the other order. I know addition is commutative, so I still get a circle, x squared plus y squared equal 1. So I can draw my circle, and now I need to figure out which direction I travel along the circle, clockwise or counterclockwise. So I'm just going to plug in just a few t values to help me figure out where I'm beginning and which direction I'm going in. So I'm going from 0 to 2 pi, so about 0. Okay, if I plug in sine 0, I get 0, cosine 0, I get 1. So I'm starting out at 0, 1. 0, 1 is up here. So this is t equal 0. Now let's put in, I don't know, let's put in pi over 2. If I put in pi over 2, sine of 2 times pi over 2, that's sine pi. That's 0 again. Interesting. Cosine of 2 times pi over 2 is cosine pi, which is -1. So I get 0, -1. Okay? So this is t equal pi over 2. From this point, it's not clear which direction I went in, so let's plug in a number in between. What about pi over 4? So I'll have sine of 2 times pi over 4, or sine pi over 2. Sine pi over 2 is 1, and I'm going to have cosine of pi over 2 as well, and that's 0. So t equals 0 was up here. T equal pi over 4 will be right here at 1, 0. T equal pi over 4. So I can see that I start out up here, and I'm going now, looks like we're going clockwise. Let's do a few more just to test. What if I plug in 3 pi over 4? If I plug in 3 pi over 4, I get sine of 2 times 3 pi over 4, or sine of 3 pi over 2. Well, sine of 3 pi over 2 is -1. Cosine 3 pi over 2 is 0. And so that makes sense. I get t equal 3 pi over 4 here. What happens if I put in my pi? Sine of 2 pi is 0. Cosine of 2 pi is 1. Okay, so I end up back here. So I've traversed the circle exactly one time in the clockwise direction, but what's the issue? I've only covered half of my values for t, right? Do y'all see that? This is only from 0 to pi. I'm interested in 0 to 2 pi, so what am I going to do? Go around the circle again. So here's my picture. Hopefully it's not too busy. I didn't want to draw the red on top of the blue because then you wouldn't be able to tell what the right shape was, but I've gone around it twice. I'm traversing the circle clockwise twice, starting at 0, 1 and going around twice, ending up at 0, 1 again. Here's another example. Sketch the curve with parametric equations x equals sine t and y equals sine squared t. Do we see a relationship between x and y? Do you see it? Hopefully you see it. X is sine t and y is sine t quantity squared, right? So isn't y equal x squared? Do you see that? Now we have to be very careful here. This is a parabola, right? Y equal x squared. But you're going to see that this parametric equation is not exactly a parabola. It is a parabola, but I have restrictions. If I write y equal x squared and I don't write anything else, there are no restrictions. But there are restrictions over here. Think about when you graph sine. All of the y values are between what and what? -1 and +1. So that means x also has to be between -1 and +1. And I know that sine has values between -1 and +1, so what happens when I square all those values? Well, the smallest value I'll get then is 0, and the largest is 1. So that means y is between 0 and 1. So I have this picture. So now we have to figure out the direction. I can pick any t value I want, but I'm going to pick ones that are easy to plug in. So if t is 0, I get 0, 0. If t is, I don't know, let's see, pi over 2, I get 1, 1. So I go this way. If t is pi, I get 0, 0, so I come back this way. If t is 3 pi over 2, I get -1 and +1, so I go this way. If t is 2 pi, I get 0, 0, and I keep going. I go back and forth, back and forth, back and forth along this parabola. So we see there's no start value, no end value. We see that in just a few values, that multiple t values get the same sign result. If I plug in sine of -t or sine of 3 pi over 2, I get -1 for that x value. So thus the curve travels back and forth, back and forth, back and forth from 1, 1 to -1, 1 along the parabola y equal x squared. That's kind of neat, right? Let's try another one. What about something like this? X equal cosine t, y equals sine squared t. So now you should have the hang of this. I know that cosine squared t plus sine squared t is 1. So then I have x squared plus y equal 1. So it looks like y equal 1 minus x squared, which we know what that is. We know that's a parabola opening downward, shifted up one like this. But the one I drew goes on forever. Do we have any restrictions on x and y? Sure we do. Since x is cosine t, I know cosine t is bounded between -1 and 1, so x is as well. And y is sine squared t, so sine squared t has a lower bound of 0 and an upper bound of 1, so does y. So I can plot a parabola similar to y equal 1 over x squared, but I have to stop at these x and y values. So here's the rough sketch. So x has what, -1 and 0, +1 and 1. So my picture looks like this. Same kind of thought as the previous one. Just goes back and forth, back and forth, back and forth along this parabola. It's pretty neat, huh?